Hi guys, this is Kiran and Charan and welcome to the channel KC PRACTRONICS. In this video, I would like to discuss on clamper. A clamper is built with two elements, a diode and a capacitor. A clamper circuit is an application of a diode. Now, what is the purpose of a clamper? A clamper is used to position the peak values and peak positive values and negative values of a given waveform. So it means that it is shifting the DC level of a given AC signal. As it can shift the peaks values of a given signal, it is also called as a level shifter. Now, what are the application of a clamper circuit? A clamper circuit has many applications in communication and electronic circuit. It is used as voltage doublers. It means it can double the voltage of a given input signal, and it is used in television receivers and radio receivers. Now let us discuss about how the clamper circuit is operated and the DC level is shifted, and then see how this is applied to these applications. Now let's see the negative clamper. In a negative clamper, both the positive half cycles and negative half cycles is being clamped to the negative side. A clamper circuit is being built by the series combination of capacitor and the diode, and the output is taken across the diode. In a negative clamper, the positive terminal of the input signal is connected to the anode of the diode and the negative terminal is connected to the cathode of the diode. When this signal is applied as an input to the circuit, the diode starts conducting over the positive half cycle and the capacitor stores a peak voltage of Vm. So the voltage across the capacitor is Vc is equal to Vm. So the capacitor is been acting as a constant DC voltage source. When we apply KVL to the circuit, Vm minus Vc equal to V0. That implies V0 equal to Vi minus Vm. So when the input voltage Vi equal to 0, then V0 will be minus Vm, and when the input is plus Vm, then V0 will be 0, and when input is minus Vm, V0 will be minus 2 Vm. This can be explained in circuit. See, the capacitor charges during the positive half cycle. It means from positive to negative. Then obviously the capacitor would discharge in the reverse direction. So when the applied input voltage is positive half cycle, then it would flow in this direction. At this moment, the input voltage and the capacitor voltage is in opposite direction. So for the positive half cycle, that is when Vi equal to 0 or plus Vm, the output voltage is being reduced, that is either to minus Vm or to 0. During the negative cycle, the input voltage will reverse and the capacitor voltage and the applied input voltage is in the same direction. So during the negative cycle, the voltage is being summed up. So now while drawing the output waveform for the first input half cycle, the capacitor will be charging and there will no output voltage appears. So for the negative half cycle, the voltage will be minus 2 Vm. When the input voltage is 0, then the output voltage is minus Vm. So it will be minus Vm, and for the positive half cycle, then it still decreases and the waveform will be as follows. So here the DC level has been shifted. Here the complete signal is being shifted to the negative cycle. Now let's see the case of positive clamper. In a positive clamper, both the positive half cycles and negative half cycles has been clamped to the positive part. Here the positive terminal of the input signal is applied to the cathode of the diode and the negative terminal is applied to the anode of the diode. Here the diode starts conducting only for the negative half cycle of the input signal. It means the capacitor stores a voltage of minus Vm. By applying KVL, the output voltage would be V0 equal to Vi minus Vc. It means Vi plus Vm. So when the input voltage is 0, then the output voltage will be Vm, and when the input voltage is Vm, the output voltage will be 2 Vm, and when the input voltage is minus Vm, then the output voltage would be 0. So we can draw the output waveform as follows. During the positive half cycle, the diode will not conduct, and for the next negative half cycle, the capacitor would charge. So for the first half cycle, there would be no voltage across output. So then as the voltage increases, so the output voltage is Vi plus Vm. So for the input voltage, an extra DC voltage of Vm is been added. So it would be like this. Here in this both positive clamper and negative clamper, the input waveform is being shifted completely either to positive or to negative. If we want to shift partially to positive or partially to negative, then we should use reference voltage. Here I have a circuit with external biased reference voltage across the diode. So this circuit is for a positive clamper circuit, as the positive terminal is connected to cathode and the negative terminal is connected to anode. So when it is biased externally with the reference voltage, the negative peaks has been clamped to VR. Like the waveform would shift further in the positive side. So here the negative peaks of the input signal is been clamped at the reference voltage. So here I have given the positive reference voltage. If I have given the negative reference voltage, the input waveform would have clamped to minus VR. So this is the case with a positive clamper. Similarly, it would apply in the case of a negative clamper. That's it all about the clamper circuit, and the only thing in the clampers is the capacitor is providing the external DC voltage source. Now let's get into the application. While transmission, we have a signal, and this signal must be sent into an amplifier for amplification. So after the amplification, the DC level of the signal is shifted. Now when this signal is transmitted, it is received by a receiver. At the receiver, we should again restore the DC level of the signal, so that if we use this clamper circuit, we can shift the DC level and can restore and match to the input signal. Clamper can be used as a voltage doubler. In general, every electronic circuit is used to function either in the positive half cycle or negative half cycle, but most of the electronic circuits designs are made to function only in the positive half cycle. So by using the positive peak clamper, if you shift the input signal completely to the positive cycle, then we can increase the efficiency. Here, if the peak voltage of the input signal is Vm, then the voltage of the output signal is 2 Vm. Hence, it is called as voltage doubler. Thanks for watching our video. In our next video, we'll come up with a new electronic concept. If you don't want to miss it, please subscribe.